And so with that, I'm happy to hand over to Daniel. He is the co-creator of Flower, and he's going to lead things off and tell us all about the massive progress we've made in the platform for us all to benefit from. So over to Daniel.
All right, thank you very much. It's really incredible to see so many of you here today. It's not that long ago that federated learning felt like sort of the best kept secret in AI, and to see so many of you here today is really exciting. Welcome to the Flower Research Update. The team has worked incredibly hard. We have many things to share today. And I can't wait to share those updates. But before I go into this and before I show what's new in Flower, I want to give a little bit of a background of why are we actually working on this. So the natural state of data in the world is it's distributed. Data is distributed across different organizations. It's distributed even within single organizations, for example, distributed across different regions for regulatory reasons. And it's distributed across user devices. So some companies, they have users, they have billions of users, and all of those users have some of the data. So this is just a natural state of the world. Now, if you look at machine learning as it happens today, usually the training happens on only just a single of those data partitions. And there's so many of them. So people are talking about GPU-rich and GPU-poor, but you could almost more important than this is probably, are you data poor or data rich? And clearly, as you can see, most of today's machine learning workloads are data poor. And they don't have to be. Healthcare is a prime example. There's a lot of healthcare data in the world, but it's partitioned, and no one has access to large enough quantities to train meaningful models. Now, collecting data is the usual approach that people try to do. They try to collect as much data as they can to make one of these partitions larger, but as we can see, this is a very limited approach. It's just unrealistic to collect way more data. Yes, you can make a licensing deal with a different company and maybe you get access to some training data, but the vast majority of data will still be inaccessible to you. Federated AI at least has the potential to solve this. It's something that I think many of us are excited about and many of us are believing in and working on. And it solves this fundamental challenge by instead of trying to move the training data, it moves the computation to where the data is. So we don't have this challenge anymore that we have to move the training data. It can stay where it is. It stays distributed in organizations, distributed across different user devices. But then we move the computation there and we allow organizations and users to keep control of their data. Now there's very different flavors of federated systems. A typical one that often gets mentioned in the press is cross-silo multi-organization. So multiple organizations collaborating. Prime example is multiple hospitals trying to train a model together. The other extreme is sort of cross-device, multi-user federated workloads, where you have a single organization, they have potentially billions of users, and they try to train models on those devices. Some other flavors that we also often come across, but that don't get as much attention usually, are cross-device single users. So for example, in a single factory, there might be multiple machines producing massive amounts of data, and it's just more practical to federate the training across these machines. And then yet another one is single silo, single organization, cross-silo, single organization, where you have a single organization that has data, for example, in different regions. As for AI research, we strongly believe there's this virtuous cycle between research and industry. Researchers, they try to experiment with new approaches that can blow up any second, and then once something starts to work, industry tries to deploy this in production, and at a scale where the servers easily could catch fire. What does great research need? We believe it needs flexibility. Researchers want to customize every aspect of their workload, It needs performance. You want to run large-scale simulations, and you want to run many of them in a short amount of time. And you need an ecosystem. You don't want to re-implement all the papers that are out there from scratch, but you want to rely on a large collection of data sets, models, aggregation strategies. In 2023, we had a number of meaningful ecosystem launches. We have Flower Datasets, the largest collection of datasets in federated learning. We launched Flower Baselines, the largest collection of baselines in federated learning. And you'll hear more about those in separate talks throughout the conference. To the first announcement of today, we're announcing Flower Discuss, a new community forum that brings the research community together. And you can join it today. It's the URL is discuss.flower.ai. Sign up and join the conversation. Benefit of the new forum is conversations are much more permanent compared to our Slack channel. So you can easily search all the conversations and bring up all replies that easily get lost in Slack. So what's next for the framework? Today we're announcing the Flower Next preview release. Last year we talked a lot about the driver API and the first prototypical release of it. This year Flower Next is here. And I want to go into a first demo. What you'll see here is a new command called flwr new that allows you to easily create a new project from scratch. So you'll give it a name, and then you can choose from a number of templates. And then you get some help in how to actually run the project. So we'll cd into the project. We'll install dependencies. And after that's done, we can simply type flwr run, which is the second new command, and run the project. While this is running, I'll quickly show you the code. What this created is a directory structure, fedlfg, and in that you have typical requirements txt, and you have a typical Python project with a init.py. You have your, because we chose the PyTorch template, you have a typical PyTorch project with a simple model in this case, you have some data loading functions, a training and a test function, and just a typical Flower Hello World project. You also have a client.py, which has your typical Flower client included, and it has a new thing called client app. Client app is how you can see that this is a Flower Next project. And then for server.py, it's similar. You have the strategy. In this case, we're just using federated averaging. And you have a new abstraction called server app. And that's how you see that the server app is compatible with Flower Next. Let's go back to the logs. We can see this is still running. It already performed a number of rounds. We also updated our logs to make them easier to parse visually. The strategy sampled the 2 clients that we're simulating. It received results. It aggregated those results. And then it went into the next round. So that's Flower New and Flower Run. What about all of those features that we often get asked about? What about differential privacy, secure aggregation, logging to weights and biases, or TensorBoard, or MLflow, how to measure bandwidth, how to measure the number of parameters that get sent back and forth, how to do checkpointing? Well, today we're introducing Flower Mods. Flower Mods is a key feature of Flower Next. This is what a typical client app looks like without Flower Mods. So you have your Flower client and then the client app thing. Now, if you want to add differential privacy and secure aggregation to that, it's just 3 lines of code. You need to import the respective mod and then add the mod to your client app. And that's how you can easily add things like differential privacy, secure aggregation, but also many other things. So in the initial release, we'll also already release a number of built-in mods for differential privacy with fixed clipping and adaptive clipping, local DP, SACAC, SACAC+, We'll have some utilities to track message sizes and number of parameters. And then we also have a bunch of other mods coming soon. For example, logging to weights and biases. Let's go into a demo. I prepared a small mod, just a Hello World mod that literally just prints two statements, one before the local training gets executed and one after that. Now we need to import it. So from that lfg.hello world, import the Hello World mod. And then, oh, that's the wrong file. This is how you can see that that's a live demo. So this is the client, and then on the client side, we simply say mods, and we add the Hello World mod. Now let's run that again. We can see it's starting again. It's launching the Ray backend. And now we can see that the two clients are already putting out the first log. So this is the hello that happens before the local training runs. And it takes a couple of seconds, the training runs, and then after the training is finished, both clients print the second log, which is Flower AI Summit. And that's Flower Mods. Next, we're introducing the Message API preview release. This is, last year we've talked about the driver API. The Message API is the driver API on steroids end-to-end, both on the server side and on the client side. On the server app, you'll get access to a driver object that allows you to send individual messages to individual clients. And this allows you to do many things like async FL, cyclic training. You can use custom for loops. You can implement custom workflows and really use this to implement arbitrary protocols on the server side. The client side and the client app supports basically the mirrored side of this. So with the client app, you can register functions at app.train, at app.evaluate, and at app.query. That's a new functionality for federated analytics to provide that in a more structured way. And then you can access the exact same message that you send from the server side, you can access it on the client side. This also enables you to have stateful computations on the client side. There's a new context, and context has state, and you can change that state. And that state only remains on the client side. So it's up to you to decide which part of your data should, which part of the basically of your local training state should remain on the client side, and what are things like evaluation metrics, for example, or model parameter updates that you want to send back to the server. This all builds on a new abstraction called record set, and record set is similar to what we had before with fit instructions and fit results, but it's much more powerful. It easily allows you to add multiple models and send multiple models. It allows you to send multiple sets of metrics and multiple sets of configuration values. What about LLMs? LLMs have proven to be incredibly useful for a wide range of tasks. And of course, we want to make Flower the best place to train federated LLMs. Today, we're announcing LLM Flower Tune. It's a friendly federated LLM fine-tuning capability. I'm going to start the demo and then introduce what you're seeing here. So this kicks off the LLM fine-tuning process. And what we're seeing here is a distributed setup, of course, with two data partitions. We have two machines running in the US. And both of these machines only have a single GPU. And they're running, we're supporting Llama 2 7B and Llama 2 3B. For the sake of this demo, we're using 3B to speed it up a little bit. And what they do is they perform federated fine-tuning, parameter-efficient fine-tuning with LoRa. And it's incredible to see how easy to use this is. And it's something that many organizations reach out to us about and are very interested in because many organizations realize that they have some data internally. There are LLMs out there, but those LLMs don't exactly do or don't perform extremely well on those tasks that those organizations are interested in. So this is a way to privately fine-tune LLMs on your sensitive distributed data. If you go back into the demo now, this is a little bit cramped because the font size is big so that everyone can read it. But you can see the training already commenced. And it started on 2 clients. And if we wait long enough, we'll see those results come back from the 2 clients and then get aggregated on the server side. And because we're using PEFT with LoRa here, the updates that get sent back and exchanged with the server are actually rather small. So we don't have to send the full 7B or Llama 2 3B model over the wire, but we're only sending pretty small updates over the wire that can easily be exchanged. All right. That's it for Flower Tune. All of what I've shown today is available in Flower Nightly. So this is not something that will come in a number of months or anything, but you can really go to PyPI, download Flower Nightly today, and use all of this. The full rollout of Flower Next will happen over Q2 2024. We're inviting everyone to try this out and to give us feedback, and we're working this feedback into the full rollout to make this a nice experience. In terms of roadmap, Flower Next rollout is the most immediate thing. We'll launch documentation for all of those features over the coming weeks. There's already a few code examples that use Flower Next, so those are the best resource for now. But of course, we'll add full documentation and tutorials for how to use all of this. For LLMs and Flower Tune, we'll also take the next steps, and we'll gradually expand the range of what Flower Tune can do. Simulations will only get faster. We built in support for multiple backends. Right now, we're using array-based backend. We have a number of other experimental backends that prove to be incredibly effective. And we are planning to use this to support very different simulation environments. So if you already have a large-scale cluster running, Flower is the best tool to integrate with that. And of course, as always, we'll provide more baselines, more data sets, and more mods. And that's it for the Flower research update. Quick summary is Flower Next, Flower Tune. Join discuss.flower.ai and take care of the incredible opportunity we have in going from data poor to data rich. Thanks.
We've got time for questions, both in the room and on Slack. Oh, let me...
Okay, 2 very quick things. So with the Flower New, is there capacity to have customized templates? And second, with regards to Flower Tune, what are the supported model architectures? Is it just Llama 2, or is there more supported? And how easy or hard would it be to add support for different architectures like Mistral and so forth?
Great questions. For Flower New, currently we have a couple of built-in templates. This is all open source, so you could easily contribute a new template. We don't have support for custom templates yet, but it's a great idea, actually. I think we haven't thought about that yet. I think this is something we could add. For different model architectures, it's actually super easy to exchange different model architectures. We just announced Llama 2, those 2 different variants, or actually 4 different variants in the example, because those are the ones that we verified, and we ran some benchmarks, and we published some performance numbers for them. But it should be incredibly easy to just switch it out to a different model architecture. It all builds on Hugging Face transformers.
Charles, anything in the Slack? I promised that we'd engage with the online folks a lot, so I want to make sure we give them a chance.
Just someone asking if the slides will be shared online.
I don't know.
Yeah,
to be honest.
but the videos will be. I guess the clean
Yeah.
answer is the videos will be shared, so that's how we'll deal with that. Any other questions in the room? Otherwise, okay. Let's thank Daniel. Thanks very much.